Hello friends, welcome to Learner's Planet. This is our very first theory session for the topic Is matter around us pure? We have already discussed about matter. What is it? And you must be knowing about it also. What is matter? Matter is anything or everything which occupies space and has mass, right? So anything which occupies space. See here, there is element, that is some element is given over here. This is occupying some space and has mass, so it is matter. Compound is here. In the compound form, say water is there. This is also matter. This is a mixture. This is also matter. Homogeneous mixture and heterogeneous mixture. So matter is anything which occupies space and has mass. Now students, this matter is composed of some substances, right? Now this substance is again composed of small atoms, that is tiny indivisible particles called atoms. Say for example this bar of metal. It is composed of small atoms over here. See, you can see the atoms here. So this bar of metal is composed of the atoms. Now these atoms are indivisible. Compound is again composed of the small particles, small indivisible particles. Homogeneous, it is homogeneous mixture. And it is composed of say two types of atoms. They are not forming the compound. Say in case of compound, these two atoms are bonded. Here there is no bond. And the heterogeneous mixture. So I can say that matter is composed of substance. Substance is made up of small or tiny indivisible particles called atoms. Now the substance can be further divided into the pure substance and impure substance. So we'll be discussing about substances, the pure substance and the impure substance in this session. So let's start our session here students. The substances. Matter is made up of one or more components known as substances. Say matter, you can take air is a matter, water is matter, right? Pen is a matter, paper is a matter. Now they are composed of some components known as substances. Now what is a substance in terms of science? In terms of science, a substance is a kind of matter, right? The substances which cannot be, now the substances, substance is a kind of matter. Now the substances which cannot be separated into any other types of matter by physical means is called a pure substance. Say if I'm taking water. Water is H2O. Now H2O, the constituents of water cannot be separated by filtration or evaporation or even distillation. Now you can't separate hydrogen and oxygen from water. So water is a pure substance. This is pure water I'm talking about, right? Water of course has impurities. The pure water if I'm taking, that is H2O, this hydrogen and oxygen cannot be separated by physical means of separation. So you can take carbon dioxide gas. It cannot be separated into its constituents, that is carbon and oxygen, by physical means of separation. Now such type of substance is called as what? Pure substance, right? So substances which cannot be separated into any other types of matter by physical means are called pure substance. Now these substances mostly mix with one another and their combination is known as mixture. Mixture is an impure substance. See these substances, like you can take carbon dioxide and water. You must have seen soda water or you must have drunk also. So soda water. Now it is composed of carbon dioxide and water. Now this is a mixture. As soon as you open the can of soda water, the carbon dioxide gas fizzles out and what is left behind is water. So soda water is what? It is an impure substance. It is composed of two pure substances, carbon dioxide and water. Likewise, I can take the mixture of salt and water. Say salt plus water. So salt water, now this salt water is also a mixture. Now what is salt? What is the formula? It is your common salt. I'm talking about common salt, the table salt which you are using. It is NaCl. Now this plus water. It gives the salt water. Now we can separate salt from water. How? If salt water is evaporated, what will happen? Water will change into water vapor. And what will be left behind is salt. So substance can be a pure substance and impure substance. Pure substance is one which cannot be separated into any other type of matter by physical means of separation. Whereas impure substance is one which can be separated. Say by filtration, evaporation, distillation or steam distillation, we can separate the components of an impure substance. And mixture is what? Mixture is an impure substance. Now let's first discuss about pure substance and the examples of it. Pure substances. A pure substance means a single substance or matter which cannot be separated into other kinds of matter by any physical process. A pure substance is made up of only one kind of atom. Say for example, metals like gold, silver, copper, iron, tin in completely pure form are pure substances. Say if I am taking gold. Gold is composed of single type of atoms. That is the gold atoms. Right? Say it is a gold bar, so it will be composed of the single type of atom which is gold atoms. Likewise silver. Silver will be composed of single type of atoms. Now by beating it with a hammer or by any other say physical process of separation, we can't separate the constituents. It will be broken down into smaller pieces, but we can't get single atom by physical means of separation. So metals are what? Metal in their pure form are pure substances. Now if I'm taking ghee or oil, vegetable ghee or oil or milk, it is not a pure substance. Why so? Because it is a mixture of many substances. So if I am taking vegetable ghee or any ghee, it is a fat, right? It is composed of many other substances. It consists of fat over there. Small amount of carbohydrate is also there. So different type of substances are present in ghee. Or oil also, there are different types of substances present. So it's a mixture. We can separate the components. Say milk. Milk is composed of the protein casein is there, right? Fat is there. There is water also. So even milk is a mixture. See, when you keep milk for boiling, what happens? The water evaporates and milk goes on becoming thick and thick, right? It consists of fat, it consists of proteins, it consists of lots of vitamins. So milk is a mixture and it is an impure substance. Whereas say you can take up wheat flour, that is also a mixture. So here also there is one more example, that is air. Air is also not a pure substance. It is composed of number of gases like oxygen, carbon dioxide, water vapors, etc. These are present in air. Blood is a mixture. It is composed of so many cells over there. Many enzymes are there, right? So blood actually consists of the blood plasma and the blood cells. Water is also there. So it is a mixture. Now these pure substances are further classified into elements and compounds. So let's discuss about the elements. Before discussing the classification, let's discuss the characteristics of pure substances. What are the characteristics which make it different from the impure substances? Say a pure substance is homogeneous throughout its mass. It is homogeneous, that is the consistency is the same, right? A pure substance cannot be separated into other kinds of matter by any physical process. This we have discussed. A pure substance has a fixed composition as well as fixed melting and boiling point. Say if I am taking water, water is a pure substance. Its composition is hydrogen and oxygen, and hydrogen and oxygen are combining in the ratio what? 2:16, or it is 1:8 by mass. Water from any source you can take, from a lake, from a river, from a pond, from your tap. The composition of hydrogen and oxygen is the same, that is 1:8. It has got a fixed melting and boiling point. What is boiling point of water? It is 100 degrees Celsius. So they've got fixed melting and boiling points. But milk doesn't have a fixed melting and boiling point. It doesn't have a fixed composition. Say it depends on the milkman, how much water he is adding, right? So the composition is not fixed. Carbon dioxide, it is a pure substance. The ratio of carbon to oxygen by mass would be, say mass of carbon is 12 and mass of oxygen is 32 in this, right? So it would be what? Further we can just do it. It will be 2, 3 and 2, 8. So carbon and oxygen are in the ratio of 3:8 in carbon dioxide. So the composition is fixed. And see, the pure substance has got a fixed melting and boiling point. So the metals like silver, gold, copper, tin, they've got a fixed melting point. Iron, but if I'm taking a mixture, it will not have a fixed melting and boiling point. Now let's discuss the classification of pure substance. Pure substances are classified into two types, the elements and the compounds. Now what are elements? The word element was introduced for the first time by Lavoisier, a French chemist. And according to him, an element is the simplest or basic form of pure substance which cannot be broken into anything simpler than it by physical or chemical methods. Right? So it is a simplest or basic form of pure substance. So element is what? It is the simplest or basic form of pure substance which cannot be broken into anything simpler than it by physical or chemical methods. Say for example hydrogen. Hydrogen, it cannot be broken into more simpler forms by any of the physical or chemical methods. Even by chemical methods also. Carbon. See if I'm taking carbon dioxide, it can be broken down into carbon and oxygen by chemical method. Right? Likewise, I can take ammonia. It can be broken down into nitrogen and hydrogen by chemical method of separation. Right? But if the elements are taken like hydrogen, carbon, oxygen, nitrogen, these elements cannot be broken down into simpler forms of matter by neither the physical method nor the chemical method. Hydrogen will be H2 and it will exist as H2. That is two hydrogen atoms bonded to form one molecule of hydrogen. Nitrogen, it exists as N2. Right? Copper exists as Cu. So element is the simplest or the basic form of pure substance which cannot be broken into anything simpler than it by physical or chemical methods of separation. Say a compound can be separated by chemical method of separation, or a compound can be broken into its constituents by chemical method of separation. Now these elements, they are also of different types. See, there is metals, nonmetals and metalloids. The elements are further classified into metals, nonmetals and metalloids. Now you must be knowing this. There are 118 elements known at present. Out of the known elements, only about 92 have been found to be present in nature. Say out of these 118 elements, which are the purest and the simplest form of matter, which cannot be separated into the other types by physical or chemical methods. That is what an element is. So 92 is found in nature and rest of them have been synthesized by the scientists. So out of 118, how many elements are known to be present in nature? 92. Only. That's it. Some elements are solid, some elements are liquid and some are gases at room temperature. Say for example, sodium and carbon are solids. Carbon exists as coke or carbon. The allotropes of carbon are graphite, diamonds, right? Carbon fibers are also there. So it exists as solid. Sodium is found as sodium pellets. So these are solids. Mercury and bromine elements are liquids. Say mercury, you must have seen it in thermometers. So mercury exists as liquid, bromine also exists as liquid. Hydrogen and oxygen elements are gases at room temperature, right? So elements may exist in all the three states. Some elements are solid, some are liquid, some are gases. Now let's discuss about metals. What are metals and what are the characteristic properties of metals? In metals, the atoms are very closely packed together and have special type of bonds known as metallic bonds. Because of close packing of atoms, metals are quite hard. Now, do you know what is a bond? A bond is nothing but a force of attraction between atoms of elements. So the force of attraction between atoms of elements is called as what? Bond. Now in case of metals, say I'm taking any metal, we can take iron also here. So there are atoms in iron. I am placing it a bit far off. So there is a force of attraction between these atoms. Now this force of attraction is called as metallic bond. And these atoms are closely packed. Say if you're taking iron only, so the metals will be closely packed. Sorry, not metal, the atoms. Atoms will be closely packed. Now they've got a closed packed structure. Because of this closed packed structure, they are hard. The force of attraction is very, very strong between the atoms of metals. Now the metals are solids at room temperature. See, you can take any metal. You can take sodium, you can take potassium, you can take gold, silver, iron, tin, copper. So these are all metals which are solids at room temperature. But one is exception. Exception is mercury. Mercury is liquid at room temperature. Mercury is also a metal, you know, but it is a liquid at room temperature. And rest all other metals are solid. So this is an exception. Do remember this. Gallium and cesium become liquid at a temperature slightly above the room temperature. See, gallium and cesium, they can melt in your hand also. So, mercury is a metal which is liquid at room temperature, and gallium and cesium, these are the metals which can melt slightly, say which can become liquid at the temperature slightly above the room temperature. Now, metals are hard. These are the exceptions, students. You should remember this. Metals are hard. Why they are hard? Because of this close packed arrangement. See, the particles, they lie one above the other and they're closely packed. They are closely packed like this. So they're stacked together. Now, so they are hard. Now again, there is an exception, students. That is, sodium and potassium are the soft metals. Sodium is so soft that you can cut it with a knife. So sodium and potassium are the soft metals. Rest all the metals are very, very hard. Mercury is a metal at room temperature, or mercury is liquid, sorry. Mercury is a metal and is liquid at room temperature. Gallium and cesium become liquid at a temperature slightly above the room temperature. I'm repeating this so that you can just remember it, right? In metals or in a metal, constituents or atoms are very closely packed in space. I have told you, they're very closely packed. The close packed arrangement is known as crystal lattice. Say for example, I can take a cubicle over here. This one, say if it's a cube. Now in this, the atoms are closely packed. The atoms are present here and they are closely packed. This is called as what? Crystal lattice. In every metal, this sort of arrangement is there, that the atoms are closely packed. They have got a crystal lattice. Now metals have a high tensile strength. That is, they are very hard. They can bear a huge amount of weight, right? So the balance which is used for, say, weighing rice or anything in large quantity, The balance which is used there is made up of iron. So that metal has got a high tensile strength. It can bear large amount of weight. Now metals are sonorous, which means when they are bent or hit, they produce a tinkling sound. You can hit any metal, say you can hit the metal bowl or the bell in the temple or any thing, any metal. It produces a long tinkling sound. So that is called as sonorous. Metals generally have high melting and boiling points. They have got high melting point. Why so? Because the force of attraction between the particles is very high, or the strong forces of attraction between the particles. So because of it, they have got high melting and boiling points. They've got high melting points, right? Metals have a shining surface. You must have seen the surface of metal. It shines. This shining surface or this property is known as luster. The silver, grey or golden yellow surfaces are there. Metals are malleable. That is, they can be beaten to form very fine thin sheets. You must have seen thin sheets of aluminium, thin sheets of gold. Say gold can be also beaten, silver can be also beaten. So they are malleable. Gold and silver metals are some of the best malleable metals. We can form thin sheets of silver or gold. They can be beaten and they can be shaped into thin sheets. Aluminium foils you must have seen in your home. They are used for packing food items like biscuits, chocolates, even the home foil, that is also the aluminium foil that is used for packing the food, right? Then the copper metal is also highly malleable. So copper sheets are used to make utensils and other containers. So metals have this very unique property of malleability. That is, they can be beaten into fine, thin sheets. There's one more interesting property of metals, which makes them of wide use, and that is the ductility. So metals are malleable and ductile. See, metals are ductile. That is, they can be drawn or stretched into thin wires. They can be stretched to form wires, right? So copper and aluminium metals are also very ductile and can be drawn into thin wires, which are used in electric wiring. So they can be drawn into thin wires, which is used in electric wiring. So metals are malleable and ductile. That is, they can be converted or they can be beaten to form thin sheets, and even they can be used for making thin wires. Metals are good conductors of heat and electricity. Good conductors of heat and electricity means they get heated up fast. Say cooking utensils and water boilers, etc. are usually made up of copper or aluminium because they are very good conductors of electricity. Because they are very good conductors of heat. The electric wires are made up of copper and aluminium metal because they are very good conductors of electricity. See, the cooking utensils, they are made up of metals. These days you can find the vessel with a copper base and rest is made up of steel. Even iron vessels were also used for cooking in ancient times. Even iron bowls are used. So they are very good conductors of heat and electricity. So metals are malleable and ductile, and they are also the good conductors of heat and electricity. So can we just revise the properties of metals? Metals are very hard. They have got a close packed arrangement of atoms, right? Metals exist as solid except for mercury, which exists as liquid. Metals are malleable and ductile. That is, they can be beaten into sheets or drawn into thin wires. Metals are very good conductors of heat and electricity, right? Metals are sonorous. Metals have got a shiny surface. Now let's discuss few properties of non-metals. How they differ from metals. Non-metals. A non-metal is an element that is neither malleable nor ductile and even does not conduct electricity. Right? Now let's discuss the properties of non-metals. Non-metals are either gases or solids at room temperature. Bromine is a liquid at room temperature. So non-metals, like the examples of non-metals like carbon, hydrogen, oxygen, nitrogen. These are all what? These are all nonmetals. These are gases at room temperature. They may also exist in the solid form at room temperature. Now, bromine is a liquid at room temperature. This is an exception, right? Now, nonmetals are neither malleable nor ductile in nature. That is why they are not used for making cooking utensils or for making wires which conduct electricity, or for making wires or thin sheets. Nonmetals are poor conductors of electricity. They do not conduct electricity, right? That is, conduct means electricity cannot pass through them. Whereas metals, electricity can pass through metals. But nonmetals are poor conductors of electricity. The exception here is graphite. Graphite is a good conductor of electricity. It is an allotrope of carbon. Say a form of carbon, right? It is a form of carbon only. So like diamond. Diamond is also a form of carbon. Graphite. That is also a form of carbon. Even your coke is also a form of carbon. So these are all the forms of carbon. So nonmetals are poor conductors of electricity. That is, they do not conduct electricity except for graphite, which is a very good conductor of electricity. Do remember this. Do remember the exception, students. Nonmetals which are solids have generally dull surfaces. They do not have luster. But again, there is an exception. Crystals of iodine have got bright luster. That is, it has got a shining surface. Whereas other nonmetals, they have got a dull surface. Nonmetals are generally soft and have smaller densities than metals. So they are generally soft. One exception is there, that is diamond. Diamond is very, very hard, and rather it is our hardest substance known. So nonmetals are poor conductors of electricity, but the exception is graphite, which is a good conductor of electricity, and it is a form of carbon. Again, nonmetals, they are soft. They have got smaller densities than metals, but exception is diamond. Diamond is very hard, and rather it is the hardest substance known. Nonmetals which are in solid state are not strong. That is, they have low tensile strength. Low tensile strength, that is, they cannot hold large weights, right? So these are the properties of nonmetals. See, nonmetals have comparatively low melting and boiling points. Metals have got what? Metals have got high melting and boiling points. Whereas nonmetals, they have got low melting and boiling points. So diamond is an allotrope of carbon which has got a very high melting point. This is an exception. Again, do remember the exception, students. Nonmetals have low densities. Nonmetals are not sonorous. So these are the few properties of nonmetals. Let's summarize it. Nonmetals, they either exist as gases or solids at room temperature. Exception is bromine. Bromine is liquid at room temperature. Nonmetals, they've got different colors, right? And the solids, which are the nonmetals which are solids, they do not have luster, except for iodine. Nonmetals are poor conductors of electricity, except for graphite. Graphite is a good conductor of electricity, which is a form of carbon. And carbon is a nonmetal. Nonmetals are soft, except for diamond, which is a form of carbon. It is the hardest substance known. Nonmetals have comparatively low melting and boiling points, right? But diamond, which is a form of carbon, has got a very high melting point. Nonmetals have low densities also, and nonmetals are not sonorous. So these are the properties of nonmetals. Now students, there are elements which have the properties of both metals and nonmetals. These elements are called as metalloids or semimetals. I'll just give a brief idea about it. There are a few elements which possess the characteristics of both metals and nonmetals. These are known as semimetals and or metalloids. Say for example, boron, silicon, germanium, arsenic, antimony, tellurium, polonium, they are all metalloids. Metalloids means they possess the property of both metals and non-metals, right? Silicon is used in your it is used in semiconductors. It is a semiconductor. Even germanium is a semiconductor, right? So these have got the properties of both metals and non-metals. You'll be studying about semiconductors in your higher grades. I don't want to go into that here. Just you remember what are the properties of metals and what are the properties of non-metals, and of course the metalloids are semi-metals. So students, these are the pure substances. These cannot be separated into any other form, right? By the physical and even the chemical method. Now I'll be concluding this session. I hope you have enjoyed this. This was just a very first session of our topic, is matter around us pure? I think it is an interesting topic. You'll find it interesting. We'll be discussing about the mixtures, the homogeneous mixture, the heterogeneous mixture, also about different type of changes in this chapter. So now I'll be concluding this session, students. Thank you, students, for listening patiently, and do have a nice time ahead.